Right, the following video is a repair of this really dilapidated 518S that's had a nasty burn up. I can smell it before I even open it up. Now, it's not going to work, it doesn't working, and it's had exploding capacitors and all sorts of crap inside it. These switches are a bit tight. Anyway, look, I'm going to repair this, but I decided just to make a step-by-step, blow-by-blow video. And the second half of this video today is a lot of rambling, soldering, speculation, fault finding, you know, hypotheses, and you know, just trying to work out what's wrong with the bloody thing, and then the repairing, and then the thought process that goes into repairing. And there's two videos; it's split into two. If you find it very long-winded, then just don't watch the second half, because it's me soldering and just refurbishing. So there's a few anecdotes and stuff going on, but otherwise, let me know if you think it's too boring. But it saves me a lot of editing, and you know, I think people that are in tune with wanting to do this themselves may find a lot of the information quite useful. I don't know. I'm passing it on because I'm retiring soon. So anyway, let me know what you think. Anyway, the video starts now. Hello, tubers. Got another one of these things. And do you know what? The more I see of these JBL 518Ss, the less impressed I am. And it's impossible to be less impressed with the design. But honestly, what a thing! It's got. You can guess what's wrong with this. Look at my hands. Look. Have a look inside. Have a look at this nasty, nasty amplifier. Right. So look at this. That has severely stewed, I would say. And it's all to do with that balancing circuit and this transistor, which drops the 360 volts or so via that transistor as a linear regulator to provide a supply for the bootstrap. Not the bootstrap, the startup supply. But look, you know, again, because of the load on it, both capacitors have been completely boiled dry or exploded. You can see all the guts have come out, and the exploding, the actual capacitor has actually blown its insides out, and then all the condensation or the chemicals inside the capacitor have come out, and you can see they've condensed on these places. Look, you see, that's all bits of capacitor guts, the guts of the capacitor in there. So bad. I know you see it occasionally, but Jesus. And we know it's not, do we know? I was wondering whether it's we can see whether it was a major transient or just a failure, can't we? So something that's dropped off down there. Is that dropped off? No, that's screwed onto the heatsink. So not great. I'll just zoom in so you can have a better look at this. It's just lovely. So we've had a hot capacitor explosion, and follow up by nasty condensation of the. It was like a. You know what they smell like, these things, when they go. But a nasty, horrible thing. Now, I could say, look, no, this is just not repairable. Or I could just chop that bit of the board out and just hot wire an alternative magic smoke solution in there. Proper circuit, a proper job, as they say. Haven't I got time? It's a matter of professional pride, I think. Look at it. Look at that. That is very nasty indeed. Right, what's further ado? Let's take it apart and have a look at it, shall we? Let's do that. Yeah, here you can get a. I've taken the power supply out, and you can look at the. You can get a view of the real level of devastation in this thing. Not pretty, is it? It's all this circuit here which drops the half B plus. Or B plus. Yeah, this bit consists of the bootstrap supply and the startup supply dropper dropping from the main 360 volt power rail in 230 volt mode. And yeah, it's a horrible thing. It's a lot of dissipation, quite high voltages on it, so it's a recipe for disaster. But you know, look at it. I mean, both these has got this balancing problem before. Both of them were swollen. That one's blown. That one's actually blown its guts out. You can see that's what sprayed everything everywhere. And yeah, you can see other bits of detritus that have blown out, that have gone all over the place. Get my kebab stick out, the old trusty kebab stick. You can see it's all piled up against the front of that little transformer down there. And generally, everything is quite corrosive, because I think these are zinc plated or galvanised or tin plated steel brackets normally, but look, it's reacted with all the zinc, isn't it, and everything. That's what's happened. But down there, it's nasty. I don't know whether it's going to work or not, but it'd be interesting to find out, wouldn't it? So there's a whole bunch of comps here. I'll draw the circuit out for you so you can have a look, see what this actually does. Interestingly, this is a slightly later version. Is it? No, I don't think it is actually. I was going to say it's got the capacity, the power balancing of these two capacitors that I did the modification on the last PRX 518, which incidentally is still going strong. Yeah, so I cleaned the back off the board, and you can see I'm thinking of getting the Dremel out. Can't leave carbonised board in a high voltage design. Cut along there, slice and remove this part of the circuit, which is only really housing a couple of components on the back here. Is then a diode, a transistor, and another transistor. The job of this transistor is to drop the momentarily drop some of the high voltage supply from these caps down to something like 30 volts until the unit starts up and the power supply fires up and starts working. All right, and then there's a winding from here which then biases this transistor off, and when this transistor is biased off, this turns off. Okay, the problem is though that when the power supply fails, it doesn't start up for some reason, it just sits there, cooks these and blows these. So it's if the power supply doesn't start, you're into a burn up situation, which is crazy, really. Crazy. So anyway, that's what's happening there. It's a horrible, nasty design. It's like a throwaway. Oh, it's the main power supply stopped switching, therefore I'm just going to self-destruct. And you can see it's got quite hot and carbonised the board, so all the glass fibre resin's been turned to carbon. So I've got carbonated glass now. So I don't know, it's probably the amplifier FETs have blown, I expect. Because the initial root cause of the problem is usually just the FETs on the amplifier going short circuit and the associated components. Yeah, you can see there's a bit of a fry up around this one, can't you? So that probably happened first, and then the inevitable happened second. Yeah, so let's have a look at that and see if the FETs have blown. I've got a stock, because after the last couple I've bought a big stock of transistors in, so I've got loads of spare parts for these now. Yeah. That's the bridge rectifier, I think. Yeah, so both FETs are gone. Quite nicely though, this has got transformer drive circuit, so not all of it actually gets back into that chip unless something's horrible has happened on the power supply line. But I suspect if I just change that FET and that FET, replace these two components, clean the board up, and then reinstate my own version of this startup and bootstrap supply switchover circuit, which is only a few transistors, I could probably just wire them together actually on a kind of open space, and then just pot the legs so they don't vibrate. I suppose you could look at it and say, you know, it's just not worth saving. There's a lot of material in this. It's got bloody white stuff all over it again. I'll clean that off. Yeah, it's a bit of a challenge as well, and you know, it sort of encourages people, if they see a burnt board, it's not the end of the world for the product. You haven't got to throw a 300 quid speaker or 400 quid speaker in the bin because, you know, 3 or 4 square centimetres of burnt track and a couple of blown transistors. So let's have a go at it, shall we? See what we can do. Yeah, stand by. Yeah, it's going to show you the bits that can happen on here. Clearly this track here has been arcing across, whether it was just got some liquid out the capacitor or, you know, ionic sort of solution stuff and arced across, but you can see that this track has been sparking across and eroded, spark eroded this connection. This is the back of one of the smoothing capacitors, the big smoothers. Actually, yeah, no, that's AC 0 volts actually, I think. Is that AC 0 volts? No, it's not. That's the B plus rail. Alright, okay. So anyway, yeah, you can see where it's been arcing across, so it does pay to have a really close look at what's been going on, really. Looks like it's been going for some time, doesn't it? That it's interesting that it's not really burnt. It's literally been sparking and just eating away at the actual connections. So what do we need? We're going to need 2 new FETs, 10k resistor probably, and that is a diode. So a new diode. Let's change that diode as well. Check these components around here up until the drive transformer, which is under this section here. There's a drive transformer. There's the complementary drive sides for the transformer to drive the complementary quadrature based or anti-phase signals to the actual FETs. And yeah, and then up here, on this side we're going to need two big capacitors. Two of these. The trouble is as well, running on 220 volts or 240 volts AC, is they've only fit 200 volt capacitors, and they really need to be 250s. So had they been 250s, then they would have been alright. So if I replace it with 200s or 250s, I'll stick a 200 volt varistor across the bottom of them to stop them getting out of balance, and also if this fault happens again, although it won't really for the new design, that they won't blow up. And then chop this out of here, and then fit a alternative start-up and 15 volt supply circuit for power up. You have to be careful actually, because although this runs on 15 volts, the normal DC running voltage of most of these chips is 15 or thereabouts when it's up and running, and the bootstrap supplying its own power. Basically it's feeding back some of the power it's pushing through to the secondary from the primary side into a little power supply to power itself. But usually there's a capacitor which charges up, and usually they take up to something like 30 volts. So this will wait until this RC network charges to 30 volts, and when it reaches certain points it will kick in and fire up the power supply. Then the charge that's held in the reservoir capacitor of that supply that's ramped up, that's charged up over time, the charge in the capacitor will supply this long enough for the bootstrap to kick in, as I explained before. And then the bootstrap takes over, and in theory it should just turn off this transistor. But if the bootstrap doesn't come, then this will sit and stew. So, you know, instead of just having a system that shut down and wouldn't run when the FETs have blown, you've got a situation where this happens, and you've got a big stew going on, a big stew of the capacitors and a big stew of that. It could be that these transistors are, because the thing about these power supplies usually is, and I'm not sure, that when these shut down and blow, if they don't blow completely short circuit, then all the power for this primary of this goes through this capacitor, is fed through a capacitor, quasi-resonant design. So that cap is, all the 500 watts is being fed through that cap, believe it or not, into the transformer. And so if they don't go short, then you've got this situation where the bootstrap supply, or actually the startup supply, is constantly on and the components overheat, and then you end up with this big fry up. One of them goes short, and then you get a cascading effect of disastrous failures. So I'm going to whip these caps out first thing, and then chop out this section of the board here, because it's no good to us, we can't do anything with that board, and then wire in the circuit, and then just probably just put an epoxy PCB, just get some. If you use JBL for example, you can put some tape over here, put JB Weld on. JB Weld's good for up to 500 volts, so it will make our own little version of an epoxy PCB with our open frame wiring. There's only literally a few connections in there, so that's what we're going to do, and we're going to see if we can resurrect this thing and get it working. So yeah, I'm not going to bother taking these caps out on camera. No, I'm not. I'm just going to take them out. So I'll see you when I've done the do. Okay. Okay, look, just got the caps out, the big ones, nice and cleanly. I was going to zoom in. You can see that little thing down there. This thing here. I'll just show you this because it's quite interesting. Interesting, yes it is. Take my word for it. Hold on a second. So we're zoomed in, look, that's, see this thing here, all this is the guts that's blown out of that capacitor when it went. Obviously it gave it a really hot supper, over voltage, boiled up inside, and explodiated, look. And if you can see that, that's all the that's all her innards blown out. And there's the base of the cap, and that's what's left of it, look. That bit there, that's just a base of a small aluminium can capacitor. Why do they use such shitty ones in these designs? It's always the capacitor, boys. It's no surprise. It's nearly always the capacitor or the FET. Why don't you protect the FETs and why don't you fit better capacitors? Ask yourselves that question. Oh, I know why the answer is. Because you want the customer to buy a new amplifier after a few years. It may surprise you to know that at the rated temperature, most of these caps have only got a rated lifetime of 1,000 or 2,000 hours. How about that? Did you know that? Look at the data sheet. RTFD. Yeah, anyway, so plenty of dirt on her. So anything else worthy of note? I don't. Ooh, hello, my camera mounts come loose. Yeah, so we've got plenty of corrosion. I haven't found the end of that cap. I don't know where it's gone. I think it's lodged in somewhere. Look, the size of that nice big varista there. Look, that's nice, isn't it? Nice big size. That's a worthy size for varista. Yeah, I don't know really, do you? They might as well try and save her just for the shits and giggles, really. Plus it's pissing down with rain and lockdown has started again in the UK and it's winter. And the builders haven't turned up to finish off my building work for like 3 weeks, so I need a distraction, frankly. Right, down to the shed, get the Dremel out. Here's an interesting one for you. This has got a problem with, when I used to run a factory, we'd get problems with outgassing in vias. When the via hadn't been plated through properly, then some of the salts from the plating bath would be stuck in the via and you get like a kind of a porous via. And when you solder it, you get a lot of outgassing, and the problem, it manifests itself as bubbles, so little bubbles of gas exploding out the via during wave solder and compromising the joint. And it was an indication you had a problem with outgassing in the boards. And sometimes they say, well, just bake the boards at 150 for 5 hours to get rid of the gases. But when you section, we used to encapsulate the board in Paxolin in a press, cut a piece of board out, put it in a press, slice it down the middle and then polish it. And then you can inspect the actual vias to make sure they were thick. So we used to have a goods inwards inspection where we would actually physically chop the boards up, polish the section, and then measure the vias on an optical microscope and just see what state they were in. And when it's quite revealing when you do that with the sort of boards that manufacturers try and palm off on you. But I just heated this one up. Watch. Can you see it gassing? See that gassing? That's coming out the board. Is that one the same, or is it just that joint? See? That one's better. That one's gassing. We can see the gas. That's a faulty via. Yep. That shouldn't gas like that because the gas is actually coming out of the board, blowing into the via hole and up like a little volcano. So see if these are the same. Yeah. JBL, check your PCB manufacturer. When you think about it, it's supposed to be a continuous copper cylinder and goes through to the other side of the board, but obviously it isn't. Come on, out you go. That's it, there's a good boy. There he is. So that's got that one out. So that's them done. If you're impressed by the power of my soldering iron, you should really if you do any degree of soldering on a daily basis, get yourself a Weller. It makes life so much easier. You can it's a 90-watt iron, and it can deliver pretty much 90 watts to the tip, to the job. Not overheating it, the temperature control is very accurate. But the power of the iron is very impressive, and if you use a substandard iron that's got poor thermal conductivity between the bit that's generating heat, i.e. the element, and the tip, then you've got problems. And this is a very monolithic block element with a kind of a silver housing on it, and it mates up right against the front of this tip. The element's a flat surface there. Very impressive irons and very reliable. You know, it might cost 300 quid. You can probably get one online second hand for 150. It's this one is a WSP 90, I think. Anyway, this is second hand one. This one, right? So we've got our transistors. I'm going to do a bit of a moppy, shall we? Just mop them up. Get rid of these blobbies. And that fella there looks all right. I'll check him. That one's got to go there. That's blown. Resistance is futile, and this is in this case because resistance isn't a resistor anymore. It was given a hot supper during the event. The 100k ones or the 10k ones are likely to be okay, aren't they? Unlikely to have pushed enough current through those to spoil those. I'm not sure about that one. May have gone tits up or not. We'll find out. Let's have a quick measure. Now we've got no transistors in there, we can measure it. Yeah, it's my good old trusty Unity. The other one's in the car. Went out and did a job. No, that's gone as well. No, that one's a open circuit, boys. Zero. Hey. Interestingly, yeah, it's open circuit. Oh no. Well, whatever it is, it's reading 30.03. It's reading 36 ohms instead of 647. So that 47 ohm, I'm going to change that as well. I think it's been compromised, don't you? Let's take it off the measure and see what she comes up with. Right. What have we got? What have we got? No, that's right. So we must be measuring the impedance of that transistor, unless it's that. That's interesting. Now I've unsoldered it. There's no short there, and that is reading 46 ohms. So obviously the act of soldering that one has changed the value of it slightly. So it was reading 30 odd before. Right. Anyway, so that's 247 ohm resistors required. 2010s are they? I think they're 2010s. I don't know if I've got any of those actually. And a bit of brushy. Bloody lockdown, eh? There's no coronavirus around here, and we've all got to stay in with the wife as well because her museum is closed. Of course, she's dreading it being stuck in the house with me. Like Benny Hill, I'll be chasing her around the house. Cue the yakety sax music, and we'll be off. Those of you probably don't remember Benny Hill, do you, in the UK? But Benny Hill was a massive. When I was in Germany in the 90s, early 90s, late 80s, Benny Hill was massive. David Hasselhoff, for some inexplicable reason, was a massive star in Germany, and Benny Hill was just like really loved. And every time you turned the telly on, it was either Benny Hill or Hasselhoff crooning away in German. But that's Germans for you. They like what they like. Right, so she's not looking as bad now, is she? Apart from that bit down there, if you ignore that, the rest of it looks alright. So I think this is rescuable, don't you? Just need to do a bit of engineering around this bit, and then we'll put some new transistors in, swap those resistors out, give this side a bit of a clean up, because look at that, that's nasty. I'm going to chop that bit out first and then proceed to clean up in an orderly fashion. Yep, I think that's recoverable. I might actually just spray these bits silver just for the hell of it, because I don't like putting them back like that. And let's see if we can get any life out of her or not. We'll find out, won't we? Yeah, I was just about to meter this transistor here as well. This series regulator transistor for the bootstrap supply. It's got some more of this stuff on it. Look. I don't know. Does anyone know if a computer guts are poisonous or not? I don't know, I might be poisoning myself. Look, just going to meter it, but then look at what I found. It's all focus your focusing thing. You can see that there. Focus. There, look. So she's got to come out as well. Poor thing. Yep, she had a hot supper. So I'm thinking of you that the B plus has got into all this circuitry down here, specifically this regulator chip, which I do have a spare one because I bought some last week. So that's going to need changing as well, I think, and possibly checking these once we've got the bootstrap working again. Yeah, so yeah, I'm just looking at it, I'm trying to get this transistor out, and I'm thinking about ways of doing it, but the prat of a designer, if they'd have put it in the other way around, I could have taken that screw out from the other side. I got a screwdriver there and undone it, and then leave the transformer forward and just dissolve the transistor. But they've faced it this way, butting up against the power transformers. So you can't get that bloody screw out. I mean, what a... If you're watching this and you're the designer, bloody... Well, just don't do that, please. The problem with unsoldering the heatsink is sometimes it takes quite a lot of heat to get these connections to go. Pain in the arse, frankly. Yeah. There you go, that's what's left of her. Managed to get her out with the mother sucker. One tip on desoldering these unleaded boards: if you suck off as much, if you melt some solder on, you know, some leaded solder onto the joint, give it a good suck, then you'll get halfway down the hole, as it were, for now. And then put some more leaded solder on it, it'll make an alloy, a lower melting point alloy that flows more easily with the new solder you've put on. So add more solder, and then mother suck again, and you can... I managed to wiggle the pins, get them loose, and actually got the... There's the transistor, look. So I only need to unsolder the front leg, the middle leg, because the others were broken off. And there's that's what happened to her. She vaporized, explosive release of the old magic smoke. Well, it's all sparkly. R.I.P. That's what I say. Well, there you can see the extent. There's the big smoothing cap on the top, and this is where the general burnout's been happening, but you can see it's the board has started to break down and spark back towards these tracks, which I guess that one goes to there. What is it? Not sure where they go. So there's the track, look, been blown off the board. Presumably that one is supposed to go off to this one, I should think, don't you? And then this one goes to one of these components. Take your pick. There is no copper left of that track, it's just disappeared. Is that it there? I'm guessing, I don't know, I'm guessing that's blown. What do you think? What do you think it's going to be like when we finish this? It's more like a restoration of an old Jeep or something, isn't it? Yeah, there's the rest of that guts out, that caplet's gone down there. It's fallen down because that's mount. There it is. Look. It's all fluffy. Should we explode a cap so if we can simulate that? It might be fun. I keep getting emails, or not emails, but YouTube messages from people saying, "Oh, can't you do some explosions? We want to see magic smoke." You're not much Magic Smoke channel. You haven't seen any magic smoke on your channel yet. That's the whole object, isn't it? Is to avoid magic smoke. But if we put our mind to creating some, we could have a bit of fun. Actually, I found out I went down to see someone the other day, and outside they put stuff outside their houses, and there was an old glass fish tank, rectangular fish tank, and I thought that would make a great exploding cabinet. Stick an extractor fan on it, and then we can blow some stuff up. So I might have a go at that. Right. Anyway, so look, we got a cut. Got a slice. That transistor's all right in that mount, so slice along there with the Dremel along this line, down there, around there, past the carbonised area. Oh no, even further to the carbonised area there, along there, remove all this carbonation, and then probably that bit's okay, would you say? Yeah, that's just green, that's not burnt. So probably along the top of that track, and then along the top of that track, and then off down here to remove all this. So I'm going to Dremel this in the bloody shed, because it's going to be a messy operation to do in the office. Did I say shed? I meant workshop. Doesn't sound very professional, shed, does it? And then down there, chop, choppy, chop, and then we'll clean up what we've got left and see just how successful we've been in removing all the detritus, carbonized PCB. No wonder look at that. No wonder it's a shit design. Look, they've used suspect capacitors, that stands for. I might change all the electrolytics, to be honest. I don't suppose any of them are any bloody good, do you? Chinese forgot to steal the whole formula, evidently, of the electrolyte. Right, so a good slicey dicey and then a blow off with the airline, and we'll be in business. I'll be back in a bit. Right, I'm back on this. I've chopped out the duff piece of board, and I've had a look around at various different power supplies I've got to provide a 15 volt. There's several iterations of this. None of these I've ever seen match the data sheet. They've always messed around with this area trying to sort out this imbalancing and this stupid linear supply issue that when the power supply shuts down, everything burns out. And the first one I did was a different iteration, different layout. This has got a different circuit, and the circuit diagram I have got for an odd version is different again. And instead of one big transistor in that position where it's gone, this thing, instead of one of those, they've got three small ones and a similar circuit but not the same. So it's a right I was going to swear there, dog's dinner. So what I have got is, I think I've looked at the spec of this chip here, the SGS5285, is it? I can't remember the number now. Now I looked at the spec of that chip. It's not one of the ones that needs 30 volts to start up. As soon as you give it, it's between 12 and 40 volts, it will start running. So I'm just going to bite the bullet and just make a simple transformer based HV reliable German manufacturer transformer, which I just pinched out of a mains monitoring unit I did. And it's 0.6 volts, 0.6 volts. That gives us 12 volts. Rectifier goes 18, and we'll just run it through a 7.9 or 7.815 volt regulator. So that will do the job for us. Okay, so I'm putting in a separate supply. I could put in the LNK 302 buck regulator. I've got a circuit board with one on I could slice out and use the power section, but why not just go for the proper solution, really? I know it's not elegant, but boy, it'll be reliable. So let's start dressing this thing up and turning it into a 15 volt supply. Yeah, located on the back of this thing is this doubling board, which has got a detection circuit. Look at all the dirt on this where it's blown up. It's got a detection circuit and another stupid dropping system and another supply to power a relay coil to switch in the doubler. We're on 240, so I'm just going to strip off the crap off this board and mount the actual power supply on that board there. So that's what I'm going to do. So I'm going to take that off and then let's work on it. Right, I've chopped all the detritus off this board. You can see all the useless crap 110 240 volt doubling switch circuit, which is we don't need that, do we, for proper volts, proper main supplies. This won't run on 110 obviously, but it'll be more reliable. Right, so I'm going to fix the transformer on there. I'm going to put some flexible adhesive on to fix the transformer on, thermal fuse, bridge rectifier, 15 volt regulator, normal fuse. There's a normal fuse in there. I might put just a normal 500 milliamp or something fuse on this, and a thermal fuse as well, glued to the underside of it, and then we'll have a safe and reliable supply. I might also just drill some holes in this board. Can I do that? No, I can't really. Put it around that way. If I mount it that way, I can bung a couple of holes and put a tie wrap around, can't I? Because we've got to also have a smoothing capacitor on here as well. Alright, so this is a good quality piece of kit actually. It's not, I've used quite a few of these in the past and they've been very good. So that's where it's going on there, and then we're going to have a 15 volt supply. Not sure about the heatsink for the 0.15. I'm just going to run it and see whether it can survive without a heatsink or not. I don't think it's going to take more than about 50 milliamps, to be honest. Oh yeah, and a bridge rectifier as well, so I've got to strap a bridge on there. So yeah, let's get on with it. So in the UK we've got a store called Lidl. They used to make or supply good tools before the pound crashed. When the pound dropped in value, we went from nice chrome and vanadium versions like this, lovely jubbly. 3 of these tools were about £6 or £7, about $10, very nice quality, including this profile, but this is a later set. I thought, I'll have another set of those. So the wife went to Lidl, yeah, come back, and they're just normal rough steel. So in Lidl, if you're watching, keep the quality up. Don't drop the price to ridiculous levels. I mean, look, it's compared to the quality of this one and that one, look, they are crap, aren't they? Let's see if I can find the same one to it. There you go. Went from $69 for these CRVs to these, which is a rough cut steel, different factory, slightly different overmolds, I think, or not. Anyway, keep the quality up. Put the price up for us a bit, will you? And just make it better, because you used to be a good source of cheap tools, but now you're a cheap source of cheap tools. What do we need? A bit of sleeving. Going to put some silicone. Bear in mind this is going to be inside a 500 watt bass speaker. That's what happens to me when my wife looks at me in that way. I just shrink. Game over. Haven't you had enough? Yes, I have. Okay, so that's that. We do need, don't we? Yes, we need to link the 2 ends of the 6-volt windings. It's a dual 606 transformer. Snip it off nice and close to the mark so we don't poke a hole in our sleeving. Poke a hole in us. Right. So that's that link there. So now what do we need? We need a thermal 133 degrees thermal fuse. Let's set that back off a bit. So this is the transformer starts to brew up inside or gets overloaded. The thing won't start smoking. It'll basically get hot, and then this one shot lockout thermal fuse will blow, which is what we want. We don't want fireworks in a customer's piece of equipment, do we? Actually, I'm going to mount that on there. Which one's the neutral connection anyway? Doesn't matter, I haven't decided yet. Yeah, I think with this 15 volt supply coming on via transformer, I might have to doctor the soft start. I don't want the power supply to start up too quick before the big capacitors have charged up, so I'm going to have to check to make sure I'm not introducing a undocumented failure mode by making sure that this is stable before we start to try and power up the well, actually both are stable before we try and power up. Otherwise we will get indeterminate, unexpected, unwanted, unloved and unacceptable and generally unnecessary magic smoke release. Right, so what do we need? We need a fuse. One moment, gonna get a fuse. Right, here we are, back again. I've got the, if you ever want to buy a fuse, then the Chinese have copied have copied all the little fuse products. They're not bad actually, I've tried these. What do we need? What do we need? What do we need? Fuses through hole with lead 5 amps. Fuse holes with lead 2.5 amps. And once again, what have we got with this one? Anyone see the current on that one? 3.15 amps. 2 amps. Ah, look. 1 amp. A little bit big, but it's better than nothing. I'd normally got a 500 or 250 milliamp, but I haven't got any. Not in that format. No, actually, while I'm at it, I know I've shouted out before, but if you need to buy loads of cheap components, LCSC Hong Kong, they arrive in about 4 or 5 days. And shipping's not bad, and they're Chinese. Well, they used to be. I don't know what they are now. They haven't got most favoured trading nation status or whatever. But they are very cheap, and they're Chinese market prices. So if you're wondering about how the stuff that comes out Chinese and so bloody cheap, impossibly cheap, then look at LCSC and you'll find out. Sorry RS, by the way, but it does encourage you to buy a volume. So it's really, if you've got quite a few to use, or you want to use quite a few, should I say. Which way we're going to go with this? Actually, like that and sleeve it up. Yeah, got a 2 kV gap there, haven't we? Not that we really need it on this, because it's an earth product, so if anything flashes over, it's going to flash back to ground. Now the question is, did you spot the deliberate mistake I just made? I just soldered on the end of a thermal fuse. But I'm 2 beers into the evening, so yeah, what did I do? Did I blow it? No, I didn't. Hee, that was good. So that's going to be bonded onto there with some thermal, not thermal, probably JB weld. Now we're on this bit, we're going to get our plus and minus emanating of 12 volts. Yeah, so we've got a bridge rectifying circuit. We've got our supply there, we've got some insulation in there so that won't short out. Got our fuses. We need to, what do we need to do? We need to see where we're going to mount this, don't we? So basically it can go on there like that, because there's plenty of room out this side. Is there? Yes there is. So yeah, I'm going to put probably some protection on there and mount that on there and put a tie wrap around from end to end. Okay, so tie wrap's going to be coming through that spot there, so tie wrap and glue, tie wrap and glue. So the capacitor, the smoothing capacitor, wants to be, I'm guessing we'll stick it on this end and then have the regulator in there. Let's do that. So what size cap are we going to need? It's going to be 18 volts or thereabouts. I've got some really nice caps here, but they're far too nice. Expensive ones actually. How about that? 1000 microfarads Nichicon. Can't get much better than that. It's big enough. Right, okay, so we're going to go on to which end? It'll be easier to mount it. The mains is over this side, isn't it? So we should mount it that way. So the negative wire, bearing in mind we're going to have plenty of bondage on this, so because we like that. Put that around there. Where's the sleeving? Your board yet? You know, you can always go and watch different channel. There's been exciting things happening somewhere else. Just want a closer look. Can you actually see what the hell I'm doing? My bloody head in the way. Probably. It's Sunday. It's gone past beer o'clock, I can tell you that. Wife's in the kitchen, cooking up a storm. So I'm soldering this onto the positive output pin of the bridge rectifier. Wonder why people think they think valves sound better, but they actually sound better because of the distortion. You know, because let's face it, a loudspeaker is not a faithful reproduction of the signal at all. Philips made a set of loudspeakers in the 70s, and if I push that up there and then I can solder it, yeah, they made a, so that's pushed in now. I'm just going to put some solder on it to make it wick up the pipe. Yeah, in the 70s they made a set of loudspeakers, and they were bookshelf powered speakers, and they had a closed loop circuit. There you go, see that? Lovely job that was. Closed loop circuit, so they had a transducer on the cone actually that fed back into a closed loop servo amplifier, so the movement of the cone was corrected, so it was supposed to give you a very accurate representation of the sound, and they were fantastic. And you can still buy them online, but they're hugely expensive. But the trouble is, when the cones blow up, you can't get them replaced. So if you do get a set, you can't really listen to them very loud, because you know it'll be curtains, and they're such a lovely thing. And it's interesting that no one's actually ever bothered to reproduce that, because I mean, my ears are a bit knackered now, but back in the day, my ears really appreciated the noise they made. Fantastic. Right, so there's our 12 volt power supply. Messy, yes. Don't need to test that bit yet, do we? So we've got live and neutral going in here. Sorry, live and neutral going in there. Okay. A bit of silicone here to protect all this. Bridge rectifier will have be adhered to the side of the transformer. Alright, so yeah, all stuck together and ready to rock and roll. So the question is, will the 7915s, no, 7815s, the plus 15 volt regulator, minus 5 volt, getting hot, warmer. Where's the positive ones? 7815s, there's 1 amp. They'll do, won't it? 78115 ABV. Look, fixed voltage regulator. 15 volt, which is what we want. That's what the circuit diagram says, but it isn't 15 really, but it'll do. Yep, 1 amp. That'll do. That'll do nicely. Very nicely indeed. Back in the bin. Right. Oh, we should mount it up that way. What do you think? No, I'm going to mount it down that way and bend the legs over. I think it shouldn't flash over. We've got to get rid of this transistor though. That's the question. Is it any good? I wonder what it is. So mains, where we're going to get our mains from? There's live and neutral down there, so I have to run some wires up from down there to the fuse, won't we? Right, no fireworks. It's actually powered up now. She's got power on her. So treat her with respect. See what we've got. There's no smoke coming off. So we want to go across that capacitor basically. Can you see? Made a right mess on this bench. Yeah, 14.74. So we've got a 15 volt power supply now, so we can power our electronics on our board. And that live neutral there is switched, so when we switch off at the back it will turn off the transformer, okay. So we've got a reliable once it's potted. In fact, I might just pot that up now and have a little rest and a beer. Come on, Christ. Right, so I got some of the old Jollop, this stuff, silicon rubber. It's like a couple of dollars a tube from Ching Chong Land, China, sorry. Lovely Chinese. And clearly it's supposed to be used in one sitting because it does get blocked up a bit. And it gets everywhere as well. There we are. Okay, so that's that done. Put some silicon along there to support that bit. Silicon down there to fix the capacitor on, silicon down the side of the heatsink to keep those capacitors away from the side. As I say, not pretty, but the alternative is to scrap this thing. Okay, that concludes part 1, and part 2 is another video. The next one I'll release will be the full repair and the detailed fault finding on the PCB and the functional test, together with a review, a few data sheets and what have you. If you've enjoyed watching, then please hit the subscribe button if you're not subscribed already, and leave me a like if you can. Well, I appreciate that.